We started the recording. Okay. Hello everyone, and welcome to Programming Workshop number 3. In this workshop, I want everyone to start out with the FTC Software Development Kit. That's what SDK right there stands for, in case any of you wondered it. And I hope you know what FTC stands for. If not, it stands for First Tech Challenge, and that's what we're doing. And I know some of you are doing FRC. That's completely fine. There are differences between FTC and FRC. I really want to... This will make it easier on me to be only doing FTC, but once you kind of know some of the stuff about both of them, or once you know stuff about FTC, a lot of it actually transfers over to FRC, so that's the reason why we're doing FTC specifically. And then also we can have 4 FTC robots, which unfortunately we don't have it today. We're going to have to wait for Riggs to get back, but we can't have 4 FRC robots just in here. They're too large. So I hope you understand. Okay, so today we're gonna have a really basic intro to GitHub and Git, and I want everyone to also make accounts. So that'll be really helpful if you haven't already. If you have, that's also amazing. And then we're gonna go over how to download the FTC SDK from the FTC SDK GitHub. And then once we've done that, which it might take a while because it takes a long time, we're going to have an introduction to op mode, hardware map motors, servos, and controllers. And that's just basically like how you control a robot, really. And we might not actually get to servos today, so but we will go over that in the near future if we don't do it today. So first, what is Git? First, does anyone know what is the difference between Git and GitHub? I want to see if anyone knows the answer. Do any of you have any idea? Okay, so basically, Git is a version control software. What it lets you do as a developer is it will create a .git folder inside of a repository you make, and you can use various commands to control different versions of your software. It's very useful, and the reason why we're going over it right now is because you need to use, you don't have to use it, but it's just very useful, and it's good to kind of learn it right away. But we're going to touch on it much later. Second, what is GitHub? GitHub is a place you can store your Git repositories. So don't confuse the two. They're completely different companies made by completely different people, but it's really easy to confuse them because the names are similar. So GitHub, and right here I just pasted the Wikipedia. It's a developer platform that allows developers to create, store, manage, and share their code. It uses Git software, providing the distributed version control of Git, plus adding access control, bug tracking, software feature requests, task management, continuous integrations, and wikis for every project. So basically it's like Git, but you can have a bunch of extra features. You can like create little issues, and then other people can see it, and then they can like create code that fixes the issue, and then like mark it as complete. And it's really good for big teams. A lot of the stuff is honestly overkill for what we're going to be doing it for, but it is a standard piece of software, and if any of you want to become software developers, it's just really good to know it because so many people use Git. And then another thing I wanted to make sure all of you know is that this workshop's going to be pretty self-guided, and that's just because I'm only one person, and I can't split myself so many different ways, but I am going to try to give everyone tools to be able to help themselves in whatever way they can. So first, before we do anything, I want to start with resources. Obviously, you got the search engine. I'm sure you've used the search engine before. If you need to look up questions, if you get stuck anywhere, before asking me, I want you to look up what you can maybe do to fix it. And a lot of these FTC things are really difficult. If you can't look it up, or if you don't think it's going to give you anything helpful, or it would just be easier to just ask me because you think it's like really quick, you could just ask. But just realize that I'm split in a lot of different ways, so try to be careful and look things up because it's also good for yourself. Sometimes it's good to struggle because that's how we learn. And then there's gm0.org. This stands for Game Manual 0. It's an unofficial FTC guide that covers a lot of the content we're going to cover in this workshop. So I want you to keep that in mind, and we're going to cover it one more time later. There's Chief Delphi, which is the forum. I'll be honest, I haven't used it all that much, but I have gotten answers from there. Sometimes when you need FTC help, Chief Delphi is a good place to look. It's just a forum. And then you can also look at the Droid Rage code bases. So you can literally go on GitHub right now and look at like past Droid Rage code, see what other people did. And this is a thing I went over in the errors workshop, which is the previous one. But I do want to show everyone like just how to do that real quick. So I'm going to go right here. What you do is you go to GitHub. Actually, it might be easier to just look up, like, I don't know, let's say 13266, because I've done most of the 13266 code. So we're going to look up this, and we can see right here, this is the PowerPlay repository. It's actually archived, because that was, what year was that? 23 or 22? I don't know. It was not this year. Most recent one, Center Stage. But you can basically go in here. You could click on FTC 13266 Apex and then look at this code. And you can even see like when people made all their commits on GitHub, what they did. And it's just really helpful to have just right here. And you can see what you could do to make a code. So I'm going in here just looking at the 13266 code. And you might not know like how to look at this repository. It can be really difficult because there's so many folders. Like where do you even start? But once you kind of know a little bit more about how FTC works, you'll kind of know it a little bit better. And we can see right here, this is an auto. And then we'd be like, oh, what's this public static? I don't know. I do know, but I know that many people here might not know exactly. Here's a teleop right here. So you could just look through code whenever you need help. You can kind of see, well, what did someone else do? That's a super helpful thing you can do to help yourself. I am recording, right? Yep. And then you can also look in the FTC robot controller folder. Now these are official samples provided by First, so you can trust them more or less if you want. But whenever you clone the project, there's going to be this folder right here called FTC Robot Controller. If you click on this right here, oh wait, it's not touchscreen, I forgot, because I didn't plug in the USB. Okay. In this external samples folder, there's a bunch of samples you can look at right here. And there's kind of a lot of them. It's very confusing. Some of this, I don't like their examples that much, I'll be honest. They're really confusing. But one of the ones I do like is this robot POV drive. And you can just look through this and see just one potential way you could program a drivetrain. POV stands for point of view, so that's like a type of drivetrain where you go like this, basically. Where basically you go forward, turn, go forward. It's just like in the perspective of the robot, basically. That's what POV means. It's, I think, what they're trying to say there. So, does anyone have any questions over anything on this slide right here? Anything you can think of? Anything confusing or you want me to go over again? So do you know how you'd access this FTC robot controller folder? Do you remember that? Okay, what about how you'd access the Droid Rage code bases? And then just gm0.org, you can just type in that website, you'll find it right there. You're going to click the software section because we're software. And then I'm sure, hopefully, you know how to use a search engine. And I wouldn't worry too much about Chief Delphi, but it'll probably come up when you look up things. So now that we've covered what we could do when we get stuck as well, which we did cover in the last workshop, but I just wanted to refresh some of the things. Let's go over what we want to do right now. And I'm going to go over all the slides, then we will follow the steps. So first thing everyone's going to need to do is clone the first Tech Challenge software development kit. And you can do this by going to their GitHub page, which you can find by just typing in FTC SDK in whatever search engine you want to use. You'll probably find the GitHub page, which looks something like this. You're going to click this little code button right here, and it'll pop out this window, and you can copy this URL to your folder. And And then you can type in inside GitHub CLI, which is a program you should have on your computer if you've installed Git. You're going to type in git clone, and then you're going to paste that link just like this. And make sure you're inside of the folder. If you see in this screenshot, I'm inside of my FTC folder. You want to make sure you're inside of, you do it inside of a directory that you want to be in. If any of you need help, feel free to ask or look it up as well. You're going to clone it into a folder you want, or you could even like clone it and then move it, wherever works for you really. And then, yeah, just do that and you'll have it. Then you're going to want to click Open Project in Android Studio. And you're going to be able to open that thing that you just made, that project you made. And here, in this case, I renamed my folder to Justin's Programming Workshop First Test. I really recommend you rename your projects because it's just going to be called FTC Robot Controller. And then you're going to be like, what is this? You're going to forget. It's a really good idea to name your projects. That'll really help you in the long run, and it's not that long. So yeah, you're just going to go, and you can, I don't know if any of you can you see this little Android icon, anyone? Yeah, so just, you'll know it's the right folder because you'll click on the little Android, and you can click OK, and it'll open it up for you. So just like that. So one thing, and really quick, how far have all of you gotten inside the Java video? Because this is we're now diving into some code. So, has anyone finished it first? Okay, 1, 2. Okay, that's good. So one of the first things you might remember from the video is that Java programs start from the main function. Do any of you remember that part of the video? The main function in Java? And how many of you know what the main function is in the program? Anyone? Feel free to raise your hands. Don't be too nervous. It's okay if you're wrong. What is it, Lucas?
The main thing you're programming, so like intake or clone.
That's a really good guess. I really appreciate that you raised your hand to say it. So Lucas said it would be like where you put your main stuff. That's what I kind of understand from what you're trying to say. In reality, what it is it's the start of your program. That's what the main function is. So I know we're going over all this, and it's really funny because in FTC, and this isn't the case in F4C, but in FTC you can't even access the main function, and I think it has to do with security or something. I'm not sure. I kind of wish we could, but you can't access the main function. There's no way to access the start of the program. So in order to tell our robot where to start, we can't just say, oh, start at main. You have to do something different. So do any of you know maybe anyone just have like any way you think you could like tell a thing to where to start? Actually, that's a really vague question. I'm going to ignore that. Sorry. That was a weird question. So the way it works in FTC is you need to create what's called a Java class. And a class is just a file. It's a .java file. Java uses these to create programs. So whenever you clone the repository, you're going to see this team code folder. Has everyone got that? So when you clone the repository, open an Android Studio, you'll see a team code folder. Inside your team code folder, you'll see a folder called org.firstinspires.ftc.teamcode. One thing really important to note, see how there's these dots here? Those dots actually represent a folder inside of a folder. So that means there's an org folder, a First Inspires folder, an FTC folder, and a team code folder. And it's like inside of it one another. That's something really helpful to know. I don't know why Java does it like this. That is just how they've chosen to do it. But this is going to just already be here. You're just going to open up this folder, and you're going to see this readme.md, which should be in there by default. And you can create a new class by just right-clicking and creating a new class. When you create a new class, you're going to be able to basically, it's just going to say public class and the name of your class. That's all it's going to be. So to make our class the start of an FTC program, we have a few key elements. The first is that we need to have what's called an annotation. This is a complex Java thing. I'll be honest, I don't understand fully how they work. But you're going to type in this @ sign, and then you type in with a capital T telly and then capital O op. And you're going to make sure you import it as well. You can just type in that line manually, or Android Studio should automatically import it for you if you just type it in. So you're going to need the @teleop, and then extends linear op mode and it needs to be capitalized like this and imported just like the op mode. So does that kind of make sense to everyone? So you create a class, which is just a .java file. You need to make it extend linear op mode and have this @teleop. Does that kind of make sense a little bit to anyone? Is anyone confused by anything? Any questions about anything? Yes. Tori? Tori. Yes, Tori, what is it?
We have to look up something on Git.
On GitHub, yes. You're going to look up, that's how you're going to find it. You're going to search up the FTC SDK, and then you're going to be able to clone it. And we're going to go over this more individually in just a second. I know we're kind of just going over a bunch of steps. I don't expect everyone to remember everything. But does that kind of answer your question, Tori? Okay, perfect. So once we have the @teleop, which tells our program this is a teleop, or it tells the FTC SDK that this is a teleop, and we say that we've extended a linear op mode, that's how it knows what class to start in. There's actually one more thing you need, which is a run op mode method. And whenever you put extends linear op mode, it'll actually turn red, and IntelliJ will actually let you right click and it'll let you fix it. But you can also just type this all in manually, but you're going to need @override public void run op mode throws interrupted exception. Don't worry too much about what that means. This is just know that this is the very start, and you're just going to have to copy paste it. I don't know. Anyway, that's how it starts. So right here, since we've extended linear op mode, we have a few different things that we can take advantage of. One of these is we can use this thing called wait for start, which is basically means we can have some code right here that let's say we want to do something on initialization. I don't know if you've ever seen this before, but some bots would close in a cone or something on initialization, or maybe grab the pixels or something like that on initialization. Or I don't know, let's say it's a disk, whatever it is. That's something very often to happen. But you only want that to happen one time. So what you can do is you can have a section of your code where it's initialization, and then you can say wait for start. So wait till someone clicks that start button to actually start the code. And then while the op mode is active, so this will just loop until you click stop. You can have some looping code here. This is a base setup for a teleop basically. And it's a little long. How many lines is this? 18, but I hope it kind of helps you. We're going to try to make one of these on our own. We'll, of course, go over this again, with everyone once everyone's ready. And just remember you have your initialization and your main loop. We're also going to cover how you can actually create things before it started, but we'll cover how we can do that, why we would do it in the future. So we're just going to ignore that for now. What if we wanted to do something? So how do we do something with our code? Well, inside of our initialization section, that's where this is happening right here. This is a common Java pattern first I want to go over. And you might have seen this inside the video. But whenever you create variables in Java, you give the variable type, the name, an equal sign, and then the value. So how could we, let's say, make something like a motor? Well, you would first specify the type, which in FTC, we generally use DC motor. You're going to give it a name. In this case, I've called it front left. I'm kind of making a drivetrain, but that's just, you could make it I don't know, let's say it's an arm. Whatever you want it to be. We don't have robots here to test, so we're not going to be able to do that in this workshop. And then you're going to put an equal sign, and then you want to give it the value. And in FTC, what we generally do is we do this thing called hardware map, which we inherit from because we extend linear op mode, hardware map dot get, and then in quotation marks, so this is a string right here, front left. So what this line will do is it will search in the hardware map for a device named front left. And then, you might remember this from the video as well, we're going to cast it as a DC motor. So you might have remember casting as integers, floats. Does anyone remember that part of the video? Okay. But it is an important part. Whenever you're creating variables, you can cast them to different types, and that will basically let it convert to different types. So here, I'm taking this hardware map variable, and I'm casting it as a DC motor to make sure that it's the correct type that we need, which is a DC motor. So this will give us an error if there's no device named front left. So it's just going to crash, turn on red. And then if front left can't be casted as a DC motor, let's say we had a servo, it'll also crash. So that's something I kind of don't like about Java. There's not really any indication that this program could crash here or could crash here. How are you supposed to know that? But yeah, it can. You can crash here, crash there. You can crash everywhere, really, in Java, it feels like. What can we do once we've created a DC motor? What do we do? Like, we have it in our hardware map. We've had the motor connected to the bot. Everything's ready. How do we make it move? Well, if you want to see what you can do with something in Java, this is in IntelliJ. This is a thing called IntelliSense, and it's super useful to every programmer. In here, does anyone remember that loop I talked about earlier? I'm going to go back to the loop real quick, just to make sure. We have the run op mode. This is the loop right here, the while op mode is active. So we have our initialization and our loop right here. This code right here, we can make something happen in our loop, which means it'll happen again and again and again and again until someone clicks stop. So inside of our loop, we can do that thing in initialization, which it is hidden. You can see it sort of off to the left, but it's partially hidden, which is DC motor FR something. We can actually reference that object we created right here by typing in front left dot. And what that dot does is it lets us access the front left motor's methods. And so these are all the functions we can use on the object. And so you can see right here we have get mode, get controller, set mode, get current position, set power, etc., etc. And a lot of these are very useful. Does anyone have any idea what might be the most useful one? Does anyone want to try to answer? What do you think might be the most useful method on the front left? Set power, that's exactly right. Yep, that's pretty much the most useful one, because that's how you make it do anything. So, what if we type in .setPower and I don't know what it does. I don't know how it works. Like, let me guess. None of you right now might know. Some of you might know, but let's say I didn't know, for example. Does it go between 0 and 100? Is the power between, negative 100 and 100? How does it work? Well, in Android Studio, and this is one of the reasons I really want to use Android Studio, you can type in .setPower, and if you hover over that word set power right here, it will literally tell you right here what it does. It sets power to the level of the motor expressed as a fraction of the maximum possible power divided by the speed supported according to the mode in which the motor is operating. Okay, whatever. Setting power of 0 will break the motor. That's a helpful thing to know. And then you can see power is the new power level of the motor, and it's between -1 and +1. So now I know 0 is going to stop my motor, 1's going to make it go forward, -1's going to make it go backward. And so it's super useful to be able to read documentation just like this, because it can be really irritating to have to look up online for every single thing. But they've written documentation inside of the code, and you can just hover over it and see it. One other thing you can do is you can control-click on this function and actually see the code behind how it works. If you're on a Mac, that would be command-click as well, I think. I don't know. I can't test it because I don't have a Mac. But you can do that to see how it works. So I have an updated version of our code. Does anyone have any idea what they think this code right here would do? Yeah, just the entire thing. Like, let's say I had this code, I had a robot, and it was plugged in. There was a motor plugged into the right port. It was named this, and I had, I don't know, let's say I had a controller plugged in, and I clicked start. What do you think it would do? Pardon, what'd you say? Move forward.
It's just gonna give power to the left motor.
Exactly, yeah. It's just going to give power. So what's that motor going to do? It's just going to go, just go. That's it. That's all this program does. It is, I think, a little bit long, but we kind of see all the steps. So does anyone want to try, because some of these things are really important. What is the hardware map? Does anyone remember what the hardware map is? Anyone want to try to answer this? Okay. What about DC motor? Pardon? It's the name of the motor. Yeah. That's basically what it is. It's the name of the motor. We're creating a motor called front left, and DC motor is the type of the motor. Front left is the name. So I kind of understand what you're saying. I don't know if that's quite what you meant, but yeah. DC motor is just what we're making, pretty much. Maybe my question wasn't very good. I'm sorry about that. And then, does anyone know what this line does right here? What does set power 1 do? Exactly, power. It just makes you go drive that one motor forward. And this is in our main loop, so it's just going to do it over and over and over again. So you might be wondering, I mean, it's, as you might know, it's not very practical to just have a motor go forever. That's going to ruin all your battery, and your robot's just going to drive away. So what would we do if we wanted to make it work with a controller? Well, we can use Gamepad 1 and Gamepad 2. And these are inherited from linear op mode. So you might remember this, but earlier I said we created a class called teleop main, and we have this extends linear op mode. This linear op mode right here is very key to a lot of the things we have access to, because you don't have access to these things normally in Java. It's because we have that extends linear op mode that we can access all these things. One of those things is hardware map, there's wait for start, there's op mode is active, and now we have Gamepad 1 right here. With Gamepad 1, and this right here, by the way, where it says Gamepad with a capital G, it's in gray right here. This is the type of the object. So you might remember we had a motor. It was called front left with the type DC motor. This is a gamepad called Gamepad 1. The type is gamepad. And types in Java usually have a capital G. So it's very helpful, something that other programming languages don't have. But having typing in Java can tell you what something is, because sometimes someone might name something and it can be really confusing, but having that type information can really help you. It's okay. Getting off track. We have a gamepad, right? Let's say I want to know what I can do with that gamepad. Remember that thing I was saying earlier? We can type in a dot. And then we can see all the fields that we have here. We have right stick button, left stick button. Does anyone have any idea what those might be?
Joysticks.
But what exactly with the joysticks?
When you press down, like.
Yep, when you press down, that's it, yeah. So whenever you click in on the joystick, that's actually a button. Yeah. They're kind of hard to press. Probably don't use those on your code. Maybe you can if you want. But, I mean, whatever. And then, what about A? Anyone know what A might be? Just the A button, that's it. You also have back and circle. Circle's for PlayStation. I'm pretty sure they actually work with each other. So if you do circle, I don't know if any of you know how the PlayStation controller works, but circle would be where B is, which is on the right. Am I right? Yeah. I think so. You have all your D-pad things. And you can access all these right here. But something to know is that these are actually not functions. And whenever you type this, it's not going to put those little parentheses. And that's because you're not calling it to do something. Instead, they're booleans. So if we wanted to do something with the controller, what we would have to do is use what are called conditionals. So in Java, you might remember being able to type if some condition, which is a boolean. What we can do is we could say if, and our condition is gamepad1.a. So if someone is pressing gamepad1.a, which is the A button on the gamepad, then we can make the motor stop, for example. So, anyone have any idea what this program would do? And we're assuming that all that rest of the code is still there. I know I've cut it out from the screenshot, but just assume it's all still there, because obviously this won't do anything on its own. So anyone have any idea what this program would do right here?
It won't give power to the front left motor.
What else? There's something else this program does.
And if you press B, it'll give power to front left motor.
Exactly. And something I like to say, I'm going to repeat what Tori said. So if you press A, it won't give power. If you press B, it will. And one other thing you might want to also think about is that this isn't just going to not give power. It's actually going to stop the power. So when you press B, it'll go. When you press A, it'll stop. Does that kind of make sense? And something like this is like a really simple code. With this alone, you could use this for like some simple mechanisms. Let's say you had a shooter, for example. You can make that shooter start with B, and then it would spin up like a little wheel that's just on a motor. And then if you touch like something to it, and it would fly away. And then obviously you don't want to waste power, so you could press A to stop that shooter. Another thing we can do is we can use comparisons to allow us to use the stick. So as you might know, a stick doesn't have just an on or an off. So that can't be a Boolean, because Booleans are only true and false. Instead, a stick has a range of values. So we need to use a comparison to convert it into a Boolean, and that will let us use it. So you can't just say if gamepad1.leftStickY. It'll be like if gamepad1.leftStickY what? If it's less than 0.5, which if you hover over it, I think it might tell you, but either way, the values range from -1 to +1 for the sticks, and they're inverted. So up is -1, down is +1. That will confuse you, because I don't know why it's set up like that. That's just how they chose to do it. Okay, so we can use comparisons to let us do things like this. And does anyone know, first of all, does anyone know what this code would do? Does anyone want to try to explain this code?
Press the left stick more than 0.5 to one side, it'll stop it. Stop the front left. If you press it more, if it's less than 0.5, it'll stop it. If it's more, it'll give it power.
Exactly. So that's just going to, you just move it. And remember, 0.5 is actually down on the stick. So that might be confusing, because you might think -0.5 is down. It's +0.5. And remember, the Y is the Y-axis, so it's up and down. So yeah, it's just going to go, when you go all the way down, it's going to, when you go more than 0.5, it's going to go to 1. When it's less than 0.5, it'll stop that motor. And second question, does anyone know what we can do to simplify this code? You're going to need to know a little bit about Java. We didn't cover it in this workshop, but if you've watched the Programming with Mosh video, you might know how we could simplify this code. Does anyone have any ideas? Yes, Lucas? Else, exactly. That's it. You got it. You can just take this out right here. Actually, I'd probably put this at the top and say, else, do something else. Because something can only be less than or greater than. I guess there's also the equal to case, but exactly. You can type else, and that will make this code a little bit simpler. So it would just go, you take this out, move it to this line, and you would type else on that. What is this? Oh, there's no line numbers. Whoops. Good job. So now we're going to finally get to the trying it ourselves. We're going to try creating our own drivetrain code. And I know I didn't go over how to create a drivetrain code at this workshop. I want everyone to see what they can maybe do to try to program their own drivetrain using what we've learned with the sticks, the buttons. And if you run into any issues, we can try to go over it, and we'll eventually go over the solution. Remember, you can look in the FTC robot controller folder for samples. If you think you can do without the samples, that's good. Try not to look too much at the samples. Remember, the FTC robot controller folder is right here, Java, external samples, and then you can access it right there. This is the sample I like the most, which is the FTC POV linear. I think it's my favorite, but you can look through the other ones as well. And then second thing is the gm0.org software section. And remember, of course, there's lots of different ways to do the same thing. So that's about it, everyone. And that's going to conclude the recorded part of this workshop. Now we're going to dive into the code.